in the real world, most of the time, one function doesn't really cover everything that you need to know. So, for example, y'all probably aren't very familiar with this, but the tax bracket, okay? Y'all, hopefully you know that based on your income, you get taxed at different rates. So if you don't make as much, typically you don't pay as much in taxes. If you make a little bit more, then you pay a little bit more in taxes, and then if you're kind of in the upper group, then you pay even more in taxes. That's the way it works. That is an example of a piecewise function because your income determines what percentage you pay in taxes. Okay, so that's a real world application of a piecewise function. So it depends on your income. It depends on your X value, so to speak. So let's look at what a piecewise function looks like. Okay, instead of just being f of x equals x squared minus 2, we've got all this extra stuff going on here. We have two functions. One part or one piece is x squared minus 2. The other piece is x plus 1. And then beside it, we have this inequality. What this is telling us is it changes. At 1, it changes. So if you're less than 1, you look at the x squared minus 2. If you're greater than or equal to 1, you're following the rule x plus 1. So I think sometimes it helps to label this, that this is the left side. X is less than 1. Now, you got to be careful. It's not always left, right. Okay, sometimes they'll put the right side first. You really do have to pay attention to that inequality. But one little trick here is that the inequality points to the direction. So like x is less than 1, the pointy end, the arrow, if you looked at that as an arrow, it would be pointing to the left. X is greater than or equal to 1, the pointy end is pointing to the right. Okay, so we've got a left side of this function, we have a right side of this function. We're going to get to graphing it here in a minute, but before we do that, let's just look at evaluating. Okay, so if I just asked you to evaluate a function, f of negative 4, what do you do with the negative 4? You plug it into the function, everywhere you see x. Well, we don't want to plug this into both pieces. Okay, this is where the inequality part comes into. We've got to figure out where this x value falls in our inequality. So negative 4, is it less than 1 or is it greater than or equal to 1? Less than 1. So that means we're going to plug negative 4 into the left function. Negative 4 squared minus 2. So that's positive 16 minus 2. So we get 14. Okay, f of negative 4 is 14. It is not 14 and negative 3. Okay, we do not plug it into both pieces. We only plug it into the one where the x value fits. Okay, so if I ask f of 0, left side or right side? Left side, because 0 is less than 1. So we plug this one into the same piece. 0 squared minus 2, well, that just gives us negative 2. Okay, f of 1. Which piece has the equal to 1? The right side. Okay, so we plug this into the right side. So 1 plus 1 is 2. Okay, and f of 2, 2 is greater than 1. So that means we plug this into the right side as well. So 2 plus 1 is 3. Okay, we could evaluate it for any number of values that we want. But those are just a few. All right, now, what if they ask us to graph it? Okay, what if they ask us to graph it? So there are a bunch of different ways that you can graph it. And I've taught it a bunch of different ways, but I think I finally decided that this is kind of the best way. Most people get it this way. So I already have a little bit of a table here, and it has a big red line through the middle of it. I know yours isn't red, but it's a big bold line right there in the middle. Because we have two pieces to this function, we're going to have two, not separate tables, but we're going to have kind of two aspects to this table. So the first part here is going to be my left side. So it's going to follow x squared minus 2 when x is less than 1. You don't necessarily have to rewrite this. I can't see my functions, so it's helping me, but I think it also helps. I do think it helps to write the function beside the part of the table that it applies to. Now, right around that big bold line, that's where we're going to start, okay? We're going to start with the x value of 1 right here at the line. I'm going to put it above it, and I'm going to put it below it, because that's where it changes, okay? That's where our function changes. X is less than 1, and x is greater than or equal to 1. So I put 1 above it and below it. We've never repeated an x value in a table before, but we need to here because we have two pieces. Okay, so I'm going to fill in the rest of the table with the x values here. So I'm going to go values less than 1, 0, -1, -2, -3. And then values greater than 1, 2, 3, 4, 5. Okay. Now, you can do this by hand, or you can get your calculator to do the work for you, but we want to plug these x values into the correct function. Okay, we want to plug the x values into the correct function. So for the first one, I'm plugging in the x squared minus 2. So if you want the calculator to do the work for you, then go to your y equals, plug in the x squared minus 2, go to the table, and we only want to copy down the y values for these x values that are above the line. So we've got 7, 2, -1, -2, -1. Then my other function is x plus 1. That's too easy. I'm not going to bother with my calculator. I just add 1 to all my x values. So 2, 3, 4, 5, and 6. Now, before we start plotting points, I've got one more thing that I have to do. Okay? Now, these are functions. So functions must pass the vertical line test. So that means that I can't have two different y values for the same x value. So I can't have two different y values for x equals 1. So one of them is going to get a point. One of them is going to get an open circle. So I determine that by which one of these has the equal to. So the first one does not have the equal to. So this one's going to get an open circle. So I write that beside my table to tell myself. Open circle there at 1, -1. The second piece is the part that has the equal to. So 1, 2 is going to be a point. So now we can plot our points. Okay, -3, +7, -2, +2, -1, -1, 0, -2, 1, -1 is an open circle. And I'm going to go ahead and connect those. This is a parabola, so I need to make it look like a parabola. I don't just connect the dots. They need to have some curve to them, right? Because a parabola has curve. Okay, so that's what the left side of my function looks like. Then I'm going to plot the second set of points that I have. 1, 2, it gets a point. It gets a closed circle. 2, 3, 3, 4, 4, 5, 5, 6. I could keep going. So I'm going to extend this part over here. Okay, so I'm just taking my table, plotting my points, making the left side look like the parabola that it's supposed to be. The right side's a linear function, so it's a line. It's going to keep going on the far right part because it's for all x values that are greater than or equal to 1. So we keep going on the right side, we keep going on the left side. Here in the middle, we've got to stop. Yes, sir. Yes, it can have more than 2 pieces. It can. We're getting ready to do one that has 3. Okay? Now, something else that they will ask you about this is this a continuous function? Is this a continuous function? No, because we've got this big old gap right here in the middle. And a simple definition of continuous is that if you start at the left side of your graph If you can trace the entire graph without picking up your pencil, then it's continuous. I would have to pick up my pencil right here. I can start on the left, we're good, we're good, we're good, we're good, but then to get from this hole up here, I've got to pick up my pencil to continue the rest of this graph. So this is not continuous. Now, you don't really, if all they ask you is this piecewise function continuous, you don't have to graph it to figure that out, okay? You just need to know, well, at the point where it changes, does it have the same y value? Okay, at the point where it changes, does it have the same y value? If it does, then those pieces are going to meet, and it is going to be continuous. These do not have the same y value, so there's a gap, so it's not continuous. Okay, let's look at one that has 3 pieces. Okay, let's look at one that has 3 pieces. Now, since this has 3 pieces, we could do like left, middle, right. But then that's just a lot of writing. So I'm going to number these. Okay, I'm going to say this is piece 1, this is piece 2, this is piece 3. All right, G of 5. Where does 5 fit into our inequalities here? The third piece. 5 is greater than 1, so we're going to plug 5 into the third piece. So 5 squared is 25. Okay, how about negative 2? The first one. Okay, the first one, because that's where it's equal to negative 2. So the first function is just x. So negative 2. Okay, G of negative 6. Where does negative 6 fall? The first one, negative 6 is less than negative 2, so that's just negative 6. How about G of 1? The second one, because that's where it's equal to 1. So we've got 1 minus 1 is 0. G of 0. G of 0. Where does 0 fall? The second one. 0 is between negative 2 and 1. Okay, so 0 minus 1 is negative 1. And how about negative 1? It's also in the second one. Okay, negative 1 is also in the second one. So we get negative 2 for that y value. All right, so when we get ready to graph this function, we have 3 pieces. It changes in 2 locations. So I'm going to, again, I'm just going to copy this down beside the sections of my table so that I know exactly what's supposed to go where. Okay, so around my big bold lines there, the first one, I'm going to put negative 2 above and below because that's where it changes. And then for the second one, I'm going to put 1 above and below because that's where it changes. All right, so negative 3, negative 4, negative 5, negative 1. That doesn't have to be that close. Negative 1, 0, 1, 2, 3, 4. Okay, usually about 2 or 3 points will be sufficient. All right, so the first piece, it's just x. It's just, your y value is just exactly what your x value is. So that's easy. And negative 2, do we have a point or a circle? Point, because it's equal to negative 2. X is less than or equal to negative 2. Okay, for the second piece, we subtract 1 from all of our x values. So negative 3, negative 2, negative 1, 0. This one at negative 2, negative 3, we have an open circle. At 1, 0, we have a point. Because the left side did not have the equal to, the right side of this part did have the equal to. Okay, the third piece is x squared, so we square all of our x values, 1, 4, 9, 16. It is not equal to 1, so this has an open circle. Okay, so -5, -5, -4, -4, -3, -3, -2, -2 is a point. That's where we stop. And we continue our line to the left. -2, -3 gets an open circle. -1, -2, 0, -1, 1, 0 is a point. There are no lines, or there are no arrows on this middle piece because we're just between -2 and 1. And then 1, 1 gets an open circle. 2, 4, 3, 9. That's as far as we can go on our graph. Be careful with this one because it's supposed to be a parabola, so try and give it some curve if you can. Don't just connect the dots. Try and make it look like a parabola as much as you can. I know it's kind of hard. There's not much room to work with there as far as making it look like a curve. Okay, this one is also not continuous. It would have to meet up at both of those places in order to be, and I misspelled it like that in first period too. It has U-O-U-S, there we go. Not continuous. It'd have to meet up at both places at -2 and at +1. They would have to have the same y values for it to be continuous. Now, I haven't given you an example of a continuous one. So there's a blank space there on your paper. We're going to make a continuous piecewise function. Okay? So, any questions about what I've done so far? I'm good with this. Okay? Also, make sure, after you finish graphing, these are functions. Functions are supposed to pass the vertical line test. So take a second, look at your graph, and make sure that it does pass the vertical line test. It's okay right here at -2 because the point is here, that's an open circle. So there's no overlap there. Okay, we're not overlapping, we're good here. One's a point, one's an open circle, we're good everywhere else. Check and make sure that it passes the vertical line test. You'd be amazed at the graphs that I've seen for these piecewise functions. Okay, lines everywhere, overlapping everywhere. All right, so let's make one up. Okay, let's make one up. So let's see here. We've used F and G. Let's use H. Nope, I wanted black. H of X. Do we want 2 pieces or 3 pieces? 2. Why did I know you were going to say that? All right, 2 pieces. Okay, so we're just building this from scratch. So let's say somebody give me a linear function. X plus 1? Is that what you said? X plus 1. All right. Somebody give me, let's switch this up. I'm going to do greater than first. Okay, just to see if we can handle that. Okay, we're going to do greater than. Somebody give me an X value. 2. All right. Okay. So, let's figure out what the other piece can be if this is continuous. Okay, if this is continuous. Okay, we want a continuous one. So that means this piece has to be x is less than or equal to 2. I do know that much. Now, I don't know what I want to put for my other piece yet. Okay, so let's do this. Okay, I don't know what I want my slope to be. So I'm going to put a variable there. I'm going to put a C. Somebody give me a y-intercept. Give me a negative number. -1. All right. All right. I like simple. Okay, nothing wrong with that. Okay, so we've got to figure out what the slope needs to be right here. So I was telling you, if this is continuous, these two pieces have to have the same y value where it changes at 2. So we know the y value for the first piece. What is the y value at 2 for the first piece?
1.
What is the y value for the first piece at x equals 2? 3, right? We just plug 2 into the equation. 2 plus 1 is 3, not 1. 2 plus 1 is 3. So that means that our second piece has to equal 3 when our x value is 2. Okay, our second piece has to equal 3 when our x value is 2. Yeah, you just worked out the whole number. All right, so we solve for c, so we add 1 to both sides. 4 equals 2c, so 2 is our c. So that means our second piece here is 2x minus 1. Okay, our second piece is 2x minus 1. So we just figured out what that had to be in order for this to be a continuous function. Now let's graph it. Okay, we know it's supposed to be continuous. Let's see if it really does end up being that way. All right, so do y'all want to make a table? Let's make a table. I think it makes more sense when we make the table. So we change at 2. So we need values less than 2, 1, 0, negative 1, 2, 3, 4. Okay, now my table is backwards from my functions here, right? Because the first part is when x is less than 2, so this is the 2x minus 1. The second part, 2, 3, 4, is when your x values are greater than 2, so that's x plus 1. So this one's pretty easy to fill in, 3, 4, 5, right? And this part is open. 2, 3 is open because it's not equal to 2. Okay, and the other one, 2 times 2 is 4, minus 1 is 3. 2 times 1 is 2, minus 1 is 2. Nope, nope, nope. Minus 1 would be 1. 2 minus 1 is 1. 2 times 0 is 0, minus 1 is negative 1. Or, hello, slope is 2. We're changing by 2 every time. All right, let's graph it. Oh, that one's a point. 2, 3 is a point because that part had to be equal to. So, negative 1, negative 3, 0, negative 1, 1, 1, 2, 3. So that's what the left side looks like. 2, 3, for the next part, I said had to be an open circle, but there's already a point there, okay? So that's the part where these are continuous, okay? 2, 3, 3, 4, 4, 5, and it keeps going. Okay, so this is finally an example of a continuous piecewise function because there's no gap there where it changes at 2. There's no gap between those two pieces. Make sense? The solving part might have been a little confusing, but just the continuous part makes sense. They have the same y value at the x value where this function changes.